Assalamualaikum dan selamat sejahtera. We continue about 7.1 acid and base for part 2. Okay, for this time I want to show you how to use ice table for weak acid and weak base. Okay, the function you use ice table is to find Ka or Kb or equilibrium concentration. Okay, for your information, ice table only used for the solution that we call as weak acid or weak base. If you have strong acid or strong base, you must use if table that I showed for the previous lesson. Okay, now we go to the question number 1, exercise 1. What is the pH of 0.5 molar HF solution? Ka given for you, HF 7.1 exponent negative 4. Okay, normally the question for chapter 7 is ask you to find the pH or pOH. Okay, if you want to find the pH, you must have the concentration H+. Where you want to find this? You can find it from ice table. If the solution you use in the question is weak acid, right, or weak base, if you want to find concentration OH minus. Okay, this HF solution is hydrohalic acid. Okay, the only one hydrohalic acid that we call as weak acid. The rest hydrohalic such as HCl, HBr, and HI is strong acid. I already told you what's the reason why HF called as weak acid. Refer to my previous video. Okay, if you want to use ice table, you have to start it with the equation. What the equation involved for this ice table? Equation dissociation. So HF dissociate in water to produce reversible arrow. Okay. Since HF is a weak acid, from Bronsted-Lowry said acid is proton donor. That means we release this H will become F minus. If this reactant as proton donor, automatically the other reactant we call as proton acceptor. That means it will accept another one H, will become H3O+. Lastly, put a phase. All the substance is aqueous except for H2O, the phase is liquid. So settle for your equation. Then as usual, ice table, the first row is inertial, the second row is change, the third row is equilibrium. Your ice table for weak acid or weak base normally in molarity, only in molarity. Okay, so initial concentration for HF is referred to the molarity here in your question. Molarity of the solution normally given for you. So this is the initial concentration for HF. H2O, since the liquid is phase, the phase is liquid, so it not involved in your ice table. Your product for inertial not produced yet. Your reactant will reduce the concentration, negative sign here. Your product will increase the concentration, so put positive sign. So equilibrium 0.5 minus x will become x, will become x. 0 plus x will become x. So settle your ice table. Then after you draw an ice table, you proceed to the Ka or Kb expression. Since you have in the question is weak acid, thus you must proceed with Ka expression. Okay, concentration, product, okay, over concentration, reactant. Okay. Then you insert the value. As usual, insert the value, just refer to the row of E, row equilibrium only. Okay. Alright. After you insert the value for Ka expression, before you write in terms of ax squared plus bx plus c equals to 0, before you expand this, you must checking first. Okay, checking 5% degree. Macam mana nak guna checking? Okay, you use this formula. Degree percentage dissociation, degree dissociation equals to Ka over concentration inertial, right, square roots, then times 100%. Okay, Ka for this case 7.1 exponent negative 4 over your initial concentration is 0.5. Okay, square root and then times with 100, and you get the value is 3.74%. This value is less than 5%. Thus, you must state that, okay, after you check the degree dissociation which is less than 5, okay, kalau dampak kurang, okay, next step, Ka very very small than 1. Okay, value Ka ni sebab negatif 4, so assume yang di bawah ini, assume 0.5 minus x approximate 0.5. So you salin semula 7.1 eksponen negatif 4 x di bawah tiada lagi 0.5 tolak x, yang ada hanyalah 0.5. Di sini saya nak menekankan, okay, checking ini diperlukan sebab sama ada kita nak buat dalam bentuk expanded ini dalam kuadratik ataupun tidak. Sebab tu kita perlu checking. Okay, kalaulah you dapat checking ini, okay, nilai ini adalah kurang daripada 5, terus you masukkan this sentence. Ka very very small than 1, assume 0.5 tolak x. Ini datang daripada mana? Ini datang daripada bahagian denominator pada expression HF ini. You ambil, you salin You buat approximate 0.5. Seolah-olah bermaksud di sini kita assume nilai X ini, nilai changes ini terlalu kecil. Andai kata terlalu kecil, let's say 0.000001. Let's say. So kalau 0.5 tolak 0.000001, kita akan dapat berapa? Nilai itu juga hampir kepada 0.5. Tiada efek sebab nilai X ini very very small. So that's why saya buat approximate 0.5. So nak mempercepatkan, so kita akan tulis 0.5 sahaja di sini. Bila tulis 0.5 bermaksud perlu tak kita nak expand jadi ax squared bx plus c? No need. So dari sini you terus proceed mencari nilai X di sini. Tanpa perlu expand menjadi kuadratik. So di sini nanti bila you cari nilai X di sini, kamu akan dapat nilainya adalah 0.0188. Bila dapat nilai X inilah mewakili concentration H3O+. H3O+ bersamaan 0.0188 molar. You have to state this first. Kita nak cari pH. Kita tahu pH adalah formula negative log concentration H3O+ ataupun H+. Di sini saya akan tulis H3O+, sebab dalam equation saya adalah H3O+. Kalau dalam equation saya H+, that means di sini pun kena H+. Tak kisah, sebab H3+ ataupun H+ adalah benda yang sama, merujuk kepada concentration datangnya daripada asid. So substitute negative log 0.0188 and you get the answer 1.73. This is your answer, pH. Inilah fungsinya kita mencari nilai X, sebab nilai X ini mewakili concentration H2O+. Kita hanya rujuk concentration H2O+ pada row E sahaja. Row equilibrium inilah menggambarkan concentration setiap spesies. We go to question number 2. Again, calculate pH of 0.036 nitrous acid. First of all, perlu tak ice stable? My answer is yes, ice stable needed. Kenapa ice stable perlu for this question? Because the solution given for us is weak acid. So you have to know either the solution strong or weak. Kalau dia weak, kena ice stable. Kalau strong, kita kena buat if table. Kalau dia strong, kita akan buat if table. Alright? So we started with equation dissociation. So nitrous acid dissociate in water to produce this is weak acid. From Bronsted-Lowry, it said that acid is proton donor. So we release this H will become NO2 minus. So the other reactant will become as your proton acceptor. So this H2O accept another one H will become H3O plus. All the species is aqueous phase except your H2O in liquid. So initial, change, and equilibrium. As usual, your unstable in unit molarity, because the species involved in your dissociation only aqueous. That's why not in ATM. Okay. So initial concentration is referred to the question given molarity 0.036. H2O not involved in your unstable, and O2 minus and H3O plus not produced yet. So decrease the concentration, increase concentration, increase concentration. So di sini 0.036 minus X become X. Di sini kita buat Ka or Kb expression, Ka expression, because the dissociation involve weak acid. So, Ka concentration NO2 minus multiply concentration H3O plus over concentration HNO2. Okay. Next, Ka is 4.5 exponent negative 4. X here, X 0.036 minus X. Okay, before you expand into AX squared BX plus C, what you should do? Checking 5%. How you want to check? Degree dissociation, Ka over concentration initial square root and multiply by 100. Okay, masukkan nilai 4.5 exponent negative 4. Okay, 0.036 square root this answer and then multiply by 100 and you get 11.18%. So this value is larger than 5%. So what you should do? Okay. Ka very large from 1. Okay. So cannot assume. Okay. X not neglected. Okay, ataupun cannot assume ataupun X not neglected. Bermaksud di sini bila you nampak nilai itu adalah nilai degree di sini adalah lebih besar dari 5%, you nyatakan ayat ini. You mesti nyatakan ayat ini. Bermaksud nilai Ka ini adalah besar daripada 1, so tak boleh assume. Bila tak boleh assume bermaksud nilai X ini, nilai bahagian bawah denominator ini kita tak boleh assume terlalu kecil. So kita akan proceed macam biasa, iaitu 4.5 exponent negative 4 X squared over 0.036 minus X. You masih kekalkan tolak X. Ini yang mau maksud cannot assume tu. Nampak dikekalkan, cannot assume. So you kena expand macam kuadratik tersebut. You kena dapat X squared plus 4.5 exponent negative 4X minus 1.62 exponent negative 5 goes to 0. So you akan dapat nilai X1 dan X2. Di sini kalau di sini kita akan dapat dua nilai. Okay, normally kita akan ambil nilai yang positif. Kalau di sini dapat positif dia sama negatif, confirm kita akan ambil ini sebagai X kamu accepted. Okay, nanti kamu kira, kamu akan dapat di sini X nya 3.806, eksponen negatif 3. Okay, kenapa kita kena ambil nilai positif all the time? Dia tak macam KC dan KP. Kenapa? Sebab ini adalah molarity. Molarity tiada bernilai negatif. Always molarity adalah positif. Yang ni, nilai molarity ni all the time adalah positif. Okay, so bila dah dapat nilai X, okay, kita tahu X ini adalah merujuk kepada concentration H2O+, juga merujuk kepada concentration NO2-. Tetapi since saya nak cari pH, okay, since kita nak cari pH, berdasarkan formula pH, negative log concentration H3O+. So X ini kita kena rujuk kepada concentration H3O+ equals to 3.806 eksponen negatif 3. So pH ini bergantung kepada concentration H2O+. That's why saya hanya ambil yang ni saja. Biasa saya nyatakan yang ini saja. Okay, so negative log 3.806 eksponen negatif 3. So we become 2.42. This is your answer for pH.